today's class, we shall see how are we going to find out the principal values of the inverse trigo functions. So in the first case, let us first of all define an invertible function. So let us first write down the definition and then understand here. Let f be a function defined from x to y as fx equal to y be a 1, 1 and onto function. So if there exists another function g from y to x, this be another 1, 1 and onto function, then g is called inverse of f, or f is said to be invertible. So now let's understand what we have written here. First of all, we have defined a function fx equal to y, and this is the function where the function is 1, 1 and onto. So the domain of the function and the range of the function in which the function is 1, 1 and onto, function defined as fx equal to y. Now supposingly there exists another function g which is again 1, 1 and onto, then g is called inverse of f. That means g is inverse of f. You can see here that g is defined from y to x. Because g is inverse of f, please see here, the domain of f is actually the range of g. The range of f is the domain of g. So that means the domain of f inverse will be same as that of g. So it has to be a function defined from y to x. Like you write down sine x equal to y. You can write the same function this way. Sine inverse y is equal to x. This is a function whose domain is all values that can be assigned to x, and the range is corresponding values of y. Because this is a 1, 1 onto function, so the invertible function is written this way, where y is now those values, y can accept those values which belongs to the domain of the sine function, and the values of x that belong to the range of the function. So this is what we'll see in little more details. So let us, as an example, consider the trigonometric function sine x, which is equal to y. Since our function is the sine function, suppose the domain of the function is the set of real numbers and the codomain of the function is also the set of real numbers. In this case, the sine function is a many 1 into function. Let's make a small change here. Instead of the codomain, let's take the range of the function. In that case, the function becomes many 1 onto function. Still one more change here. Let's change the domain of the function and consider the domain as a subset of domain as the closed interval from minus pi by 2 to pi by 2, and the range of the function as a closed interval from minus 1 to 1. In this case, the function becomes 1, 1 on 2 function. So you can see here, depending upon the domain and the range of the function, the kind of function will always keep changing. We are interested in this function. Now here you notice that the function is 1, 1 and on 2. It is 1, 1, the domain of function is this. It is on 2, this is the range of the function. Now because here the function is 1, 1 and on 2, that means this sine function is invertible. If it is invertible, the invertible function is represented this way. And we have just now seen that for an invertible function, the domain and range will interchange. That means the domain of the sine inverse function is this, and the codomain of the function, the range of the function will become this. To have a clear picture of this, let's take an example. Considering this equation only, okay, putting some values of x and finding out corresponding y. So here what we are looking at, the sine function. So I'm taking here sine, say pi by 3 radians, and the value is root 3 by 2. So you can check here that in this sine function, this is the domain of the function. So we have chosen one angle from the domain of the function. The corresponding value of the sine function is root 3 by 2, which is approximately 0.8, and this value belongs to the range of the function. The same equation can be written as sine inverse root 3 by 2, which is equal to pi by 3. The same equation can be written like this. Now we are referring to the sine inverse function. So you can see the sine inverse function here. This is now the domain of the function. Domain of function, which is approximately 0.8, lies in this interval. The corresponding value of the inverse function belongs to the range of the function. So this way you can see, for a function and its inverse function, the domain and the range always get interchanged. Now let us draw here a table where I'm going to write down here the inverse trigo function. Here we shall write down the domain of the function, and here we'll write down the range of the function, which is also the principal branch of the function. So let's start from the first function, that is the sine inverse function. Now looking into this graph here, you know the domain of the function is minus 1 to 1, and the principal branch is the closed interval minus pi by 2 to plus pi by 2. Okay, look into the next graph, the cos inverse function. Looking into that graph also, we again get to know that the domain of the function is this, and the range or the principal branch of the function is the closed interval 0 to pi. Next we move on to the graph of tan inverse function. Then looking into the tan inverse function, the principal branch is shown here. So according to that, the domain is R, and the principal branch of the function is the open interval minus pi by 2 to plus pi by 2. Look at the graph of the cot inverse function. Here again the principal branch is shown. So that tells us that domain is R, and the principal branch is the open interval 0 to pi. Graph of the sec inverse function. The domain of the function is set of all real numbers except this open interval, and the principal branch is the closed interval 0 to pi except the angle pi by 2. The next graph that you see here is the graph of the cosec inverse function, and this is the domain of the function, the range of the function is this except the angle 0. So these are the principal branches. So this is what we have to always keep in mind. For every inverse trigo function, we should know what is the domain of the function and what is the principal branch of the function. Now we are going to look at these angles very carefully. When you look at this branch, you get to know that there are some angles positive and there are some angles negative. Here all angles are positive. Here again some positive and some negative angles. Here again we have negative angles, and in these two branches we have positive angles. So where are these positive and negative angles? That's what we see now. So y-axis, x-axis. Now you know that if you start measuring the angles from the positive x-axis and you move in the anti-clockwise direction, you have positive angles. So the first quadrant, second quadrant, third and the fourth quadrant. In the first quadrant, the angles lie between 0 and pi by 2. So positive angles. In the second quadrant, the angles lie between pi by 2 and pi. So positive angles are all in the first and second quadrant because the largest positive angle that we have is pi radians. Now there are some negative angles also. So we know by basic trigonometry that once again if we start measuring the angles from the positive x-axis and we move in the clockwise direction, so here we have the negative angles, and these angles lie between the range 0 to minus pi by 2. So here there should be no confusion that this angle is less than 0 degrees. It's not a concept of integers. The minus sign simply tells us the sense of rotation. Alright, so that means whenever we have negative angles, the negative angles will lie in the fourth quadrant. When we are talking of positive angles, those angles lie in the first quadrant and in the second quadrant. So here you see that when we are referring to the principal branch of the sine inverse function, we can write down the quadrant in which these angles lie. So minus pi by 2 to plus pi by 2 means from moving on from the negative y-axis to the positive y-axis. That means we have the first quadrant and the fourth quadrant. Likewise, for the cos inverse function, the principal branch is 0 to pi, so which is the first and the second quadrant. First and second quadrant. Then over here, once again we get to know it is the first and the fourth quadrant, first and second quadrant. Here again, first and second quadrant, first and the fourth quadrant. When you look at these quadrants, one thing is very clear, that the first quadrant belongs to the principal branch of all the inverse trigo ratios. The third quadrant does not belong to any of the principal branches of the inverse trigo functions. In some of these principal branches we are using the fourth quadrant, whereas in the others we are using the second quadrant. So for the fourth quadrant, I'll just write down here that here our angle is say greater than 0 and less than minus pi by 2. Whereas in the second quadrant, the angle is greater than pi by 2 and less than pi. And the same thing follows up here. So what is the idea of studying the quadrants which belongs to these angles? These quadrants basically help us to understand how can we find out the principal values. Now see, in the last class we have seen that any trigonometric function, the domain of any trigonometric function can be divided into various branches, and in each of those branches the function is 1, 1 or 2. So the results for each of these branches are different. According to the CBSE syllabus, we only have the principal branch. So whatever we study will have a reference only to the principal branch. So now let's see how are we going to use the result. So suppose we want to find out sine inverse root 3 by 2. So by basic trigonometric knowledge, let us consider that sine inverse root 3 by 2 is suppose theta, so that sine theta can be written as root 3 by 2. This is a kind of equation we are usually familiar with, And we know according to this, either we write down this step that sine theta is sine of pi by 3. So we know that theta is pi by 3 and this angle belongs to the principal branch of the sine inverse function. So for sine inverse function, we were finding out theta and that theta is pi by 3 and this angle belongs to the principal branch. Here you can also notice, instead of doing all these steps, we can skip these steps and directly write down this result. So for this, we will make use of these quadrants here. Let's see how. So start from here. This value is positive. If this value is positive, that means the angle will always lie in the first quadrant. And in the first quadrant, we know the angle has to be an acute angle. So you find out what is the corresponding angle whose sine ratio gives us root 3 by 2. By basic trigonometry, we know it's pi by 3. Supposingly, we want to find out sine inverse of minus root 3 by 2. So this negative value tells us that now the angle does not lie in the first quadrant. So where will it lie? It will lie in the fourth quadrant. So we can directly write down the angle in the fourth quadrant, and the angle in the fourth quadrant has to be negative. So it is minus of some value. Which value? The acute angle corresponding to value sine ratio root 3 by 2. So that value is pi by 3. Hence, we are able to obtain this angle which belongs to the principal branch of the sine inverse function. So all in all, what are we trying to do? We are simplifying these kinds of questions to find out the angle, and we are ensuring that whichever angle we find out is either in first quadrant or in fourth quadrant, or to put it in other words, the angle belongs to the principal branch. So I am going to try out the questions directly this way. So trying to skip these steps. Now suppose we want to find out value of cos inverse 1 by 2. Again, see, this value is positive. That means positive value means the angle has to be in the first quadrant. If it is in the first quadrant, the corresponding value for the cos ratio 1 by 2 is pi by 3 radians, and this angle belongs to the principal branch of the cos inverse function. This is what we can always cross check. If we want to find out value of cos inverse minus 1 by 2, notice value is negative, so that means theta is not in the first quadrant. If it is not in first quadrant, where is it? It is in the second quadrant. Second quadrant angle is less than pi. So we can find out the angle as pi minus something. Something is what? An acute angle which corresponds to cos of some angle giving value 1 by 2, and that angle is pi by 3. So we get an angle 2 pi by 3 which is 120 degrees, and we know this angle definitely belongs to the principal branch. So next, let's find out for the tan ratio, tan inverse root 3, positive value. So theta is in the first quadrant, and we know that tan of 60 degrees is root 3, and this angle belongs to the principal branch of the tan inverse function. Supposingly, we want to find out tan inverse of minus root 3, negative value. So angle is not in first quadrant. So where is this? So for the tan inverse ratio, you can see if it is not first quadrant, it has to be in the fourth quadrant, and in the fourth quadrant angles are negative. So minus of some acute angle, the acute angle corresponding to tan ratio having a value equal to root 3, and that angle is minus pi by 3. This angle also belongs to the principal branch of the tan inverse function. Next, let's find out here, say cot inverse 1 by root 3, value positive. So angle is in the first quadrant, it is some acute angle, and the corresponding value would be pi by 3 radians, and this value belongs to the principal branch of the cot inverse function. See, the cot inverse function varies from 0 to 180 and 60 degree lies in that principal branch. If we want to find out cot inverse of minus 1 by root 3, value is negative, so theta will lie for the cot inverse function in the second quadrant, and in the second quadrant the angle is expressed as pi minus the acute angle, so this value turns out to be 2 pi by 3, which is 120 degrees, and this for surely belongs to the principal branch of the function. So now in a similar manner, let us find out here value of sec inverse root 2. Positive value, so angle is in first quadrant, and we know this value is pi by 4 because sec pi by 4 is root 2. And this value belongs to the principal branch of the sec inverse function, which is this. Alright, next let us find out value of sec inverse minus root 2. Now here, since this value is negative, so for the sec inverse function the negative value will lie in the second quadrant, and in second quadrant it is always pi minus the acute angle pi by 4. So this is 3 pi by 4, 135 degrees, which belongs to the principal branch of the sec inverse function. In a similar manner, we can find out cosec inverse root 2. Positive value, so the angle is an acute angle, and this angle will of course belong to the principal branch of the cosec inverse function. If it is cosec inverse minus root 2, so we know now the angle does not lie in the first quadrant. For cosec inverse, it has to lie in the fourth quadrant, and in the fourth quadrant the angle is negative angle, negative minus pi by 4. So this angle once again belongs to the principal branch of the cosec inverse functions. So this way, these are very, very simple questions. Like in exam, we may get a question for 1 mark of this kind. For example, it is tan inverse minus 1 plus sec inverse minus root 2 plus cos inverse 1 by root 2. Alright, let's try out this question. That means you're finding out here 3 values, and for that you get 1 mark. So tan inverse minus 1. Again, quickly revising our concepts, value negative, so it will not be in the first quadrant. So for tan inverse, it has to be fourth quadrant. Fourth quadrant angle is negative. This is it. Now similarly, for the sec inverse function, value is negative. Looking into here, negative value will belong to second quadrant. So second quadrant, it is pi minus an acute angle, and that acute angle is pi by 4. Likewise, this value is positive, so it will be in the first quadrant, and hence it is this. So these two values get cancelled, and on simplifying you get here a value 3 pi by 4. So these are simple questions, but these questions have to be done very, very carefully, because as you can see, these are kinds of questions which have been asked in the board exams. There are 3 major steps. One of the steps goes wrong, so either you may get a 0 or maybe you get only a half mark. So there are some more important steps here. Every step has to be done very carefully. So with this concept of principal values of the angles of the inverse trigo functions, you should be able to solve the first exercise of the NCERT textbook.